Most people in the room developers here? Yeah, okay. So it's May, so we're almost 6 months into the year. So it'll be interesting to find out how your year has been so far in terms of your experience of production issues. Yeah, have a seat. We haven't started properly yet. So put your hand up if you've had a major production issue in the last 6 months. Great, excellent, okay. Put your hand up if you had one in the last month. Yeah, okay. Anyone had one last week? Okay, it's been a quiet week. And now put your hand up if you had a production incident that lasted for more than an hour this year. Right, okay, great, that's kind of a rough idea. Okay, with that, let's probably set the scene, so let's make a start. Hello, you're welcome. So my name's Lyndsay Prewer, and over the next 45 minutes or so, I'll be sharing my experience with you of how we can learn more about the resilience of our systems and improve the resilience of our systems through running what I call chaos days. And this experience report is based on work I've done in lots of different organizations that have large platforms. So platforms with tens of teams, often with some teams providing platform-based services. We've helped those organizations to design and run chaos days so they can deliberately cause failures on their systems and use those failures to learn how they can improve the resilience of their systems and their processes and their people. So before we can talk about the detail of it, let's just agree what is chaos engineering, and let's talk about why it's important, because it's a term that it gets thrown around a fair bit. Chaos engineering is important because, firstly, you've all shown that production incidents do happen. It's not a matter of if, but when. It's also really important because these days you can build some amazing things really, really quickly. You can use cloud APIs and kind of different frameworks to really quickly, especially with a group of smart people and lean and agile practices, create something that is connect some device in your home, like your central heating system or your lock or your sound system, to a device on to your phone, so you can control those things with your phone, and you can have all that data going from your phone to your device up into the cloud, so that I can turn my heating on at home, which is a few hours away, from here right now if I wanted to, and it's brilliant having that control. You can do that kind of thing really, really fast. When you're working at planet scale, like we can easily do now with cloud services, especially if you're using cloud services from a really solid, strong multinational company like Google or Amazon, it's never going to go wrong, is it? Because they are really reliable, they're rock solid. Well, that's not strictly true. I don't know if any of you have had outages on Google Cloud or Amazon Cloud, but this particular one caught my eye a few years ago, where an outage in Google's networking layer, I think in the East Coast of America, combined with a few other issues that meant people's Nest system, their home automation system, stopped working. So that meant if you were relying on your phone to be able to open your front door through a smart lock, you couldn't get into your home. Or if you wanted to make your house a bit warmer or colder, you couldn't do that from your phone. You actually had to get up from your chair and walk, which was this was a major problem for many people. There was quite a few tweets about it. Whenever I see this kind of thing happen, it's fascinating and fun, but it's even more interesting when the post-incident review gets published. And I love companies that are very honest and transparent with their post-incident reviews and go into lots of detail. And the interesting detail here, which is why it's so appropriate for chaos days, is that this wasn't just one bug that happened. And large-scale production issues generally aren't just a single bug. This was 2 misconfigurations and a bug, so 3 things combining in a particular way that's completely unforeseen that caused this massive problem that affected thousands of people. So with that in mind, why does chaos engineering help? Well, chaos engineering helps us understand what can go wrong and how we can make our systems more resilient in the face of things going wrong. Have a think about something you're working on currently or worked on recently think about how is that system made up? What are the component parts that you and your team have built themselves? How are those parts connected to each other? They're using REST APIs, they're using sockets, they're streams. What are the forms of communication between those parts? For each of those components, be they microservices or modules or libraries or different processes running in different places, how reliable are they? Do you know under what situations they will fail? How reliable are the connections? Do the connections sometimes go down? Do you suffer from latency or loss? Now, what happens when one of those components or connection fails in your system? What happens if lots of them fail all at the same time and in different ways? Can you predict what's going to happen in your production system when that kind of situation occurs? Now, for a lot of us, the systems that we work on are like the one in the far left. They're complex systems. If you're fortunate enough to work on a really simple system, then this talk probably isn't for you, because a system with two parts, one connection between them, you can probably fairly easily predict all the things that are going to go wrong and the impact they're going to have. So with complex systems, engineering, I'll try not to move my arm. Chaos engineering helps because we can deliberately design experiments where we induce failures. We can observe those failures, understand how do they ripple through the system, how do our teams notice them, how do our teams respond and diagnose. And through that observation and that learning, it helps us to improve resilience of our system by putting resilience into our processes, giving people the knowledge to respond better, and designing our systems better. Chaos engineering, most importantly, helps teams think about production the whole time and think about failure the whole time. So rather than being something that they only think about when production is on fire, it means they start thinking about production failures and how they handle unexpected results much earlier in the engineering process. I'm going to use the word resilience an awful lot in this talk, so I thought it would be useful just to agree on a definition. By resilience, we're not talking about a system that's bulletproof, that never fails, that never breaks. Resilience is all about recovery. There's a good metric, the mean time to recover. It's how do you minimize the time it takes for your system to recover, because your system will fail. I think the survey we did at the beginning just shows that. And it will fail lots of times. So it's not a question of if it fails or wanting to never allow it to fail. It's a question of how quickly can your system fail and recover. Can it fail gracefully so that people don't know? Or can it fail but then recover really, really quickly so there's minimal impact? I'm going to talk about 4 forms of chaos engineering, go briefly through each of them, and then major on chaos stayers, which are classed as a manual form of chaos engineering. You can start guessing what the 4th form is. It's something we've talked about already. My clicker is very... There we go. So manual chaos. So manual chaos engineering is where you're doing things in a kind of a fashion where you decide up front, okay, what are we going to try and break? What experiments are we going to run? And do it just for a particular day or week. It might also take the form of something like an AWS game day. Has anyone in the room done an AWS game day before? No? Okay, if you're near an AWS center, look them up. They're quite good fun. AWS put them on for free, and it's a chance to go work with other people, and they'll simulate a production system, give you some basic instructions on how to observe it, how to operate it, how to control it, and then they'll start degrading the performance of that system. And it's quite intense, and you learn, how do systems fail? Why is it important to be able to observe these systems? What options do you have for improving their resilience? There's also change-specific chaos, which is where you look at each change or capability you're adding into your system and think throughout the design and engineering process, how could this fail? What's the acceptable failure conditions? What's unacceptable? What improvements, design decisions do we want to make regarding different failure modes? Next, we'll talk about automated chaos. This is probably the term that became more famous through Chaos Monkey. that is where the term chaos engineering came from. Are any of you using preemptible VMs or AWS Spot instances? Yeah? Okay. So if you're not aware of what those are, these are compute instances in the cloud that will at some point be terminated. And your system might get a notification of being terminated, but you can't guarantee they're going to be up forever. And you get a kind of a lower price for those compute instances. Working with preemptible VMs or spot instances is a great way, effectively, of automating chaos engineering, because you're having to design the services that run on those systems to handle their host being shut down. And it makes you start thinking about designing services that have to move around in terms of which host they're running on. You can also invest a lot more money and automate your chaos engineering by actually coding in failures on a production or pre-production system using some of the frameworks that Netflix made famous and open sourced in the form of Chaos Monkey. AWS also provides a suite of tools now where you can run failures on your network, simulating all sorts of different kinds of problems. One organization I worked at, we had a hackathon, and the team there came up with this randomized pod killer that's shown over there. So they hooked up a Nintendo emulator with Super Mario Bros. And they hooked it up to a Kubernetes cluster so that every time Mario died, they randomly killed a Kubernetes pod. Now, which is quite good fun for people playing the game, not so much fun for everyone else. Another form of chaos engineering is what I call in-process. This is probably one of the more mature forms of chaos engineering. That's where your teams have got used to thinking about failure and resilience from the very outset. And it's not just the engineers that are thinking about it, it's the product managers, business analysts, QAs. Continuous delivery has become successful by people thinking about how to build quality into their products from the very, very outset. And that's allowed them to get to production with kind of less defects much faster. The same goes for chaos engineering. If your whole team can be thinking about failure, about production behavior, about resilience from the very outset, so understanding what kind of failure budget we want to build into our services, because it will fail. So what is acceptable in terms of how long it could fail for? When it fails, how do we want to know about it? What kind of observability do we want to build in? So you think about those things at the very outset. You build them in, and you sort of write tests around them wherever you can. And then you deploy them, and you start testing different failure modes as early as possible, not waiting for your first production outage as the way that you test and learn about failure. I highly recommend this, that if you can get to this level of process, then it will make your systems and your teams much better to handle failure. So the fourth type of chaos engineering is something that we've talked about already, which is unplanned chaos. And this is great because it's free, it takes no setup time, you wait for a production issue, and there you have a chaos day. This is a very common approach to chaos engineering. You can get a lot from it, but I don't recommend it as your only strategy. If you have production incidents, then, which you will do, try and learn as much as you can from them. One of the best ways of learning from them is to develop a lot of discipline on how you firstly respond. So make sure that people are reflecting on the processes they go through to respond to these production incidents. Make sure that they're documenting exactly what are they observing, what are they learning, what are they seeing, how are they responding. Then learn how to run post-incident reviews really, really well. There's a growing amount of information on the web from organizations like Etsy, Google, Amazon, on how you can run post-incident reviews and get the most from them. The airline industry has made huge advances in safety through improving this kind of process. And that knowledge is now transferring over to the software industry. So I highly recommend looking at some of the links that will be in the slides afterwards. There's also various tooling you can get now to improve how you document your response to an issue. And that also helps when you're doing the post-incident review to go through and learn, how do people know where to look? How do people know, what component was actually causing the problem? What red herrings come up that distracted people? All of these reflections give people knowledge that they can then apply to the next time an issue happens. One really important thing about production instances is that often your manager will say to you, okay, tell me what happened, tell me what was the root cause, and then tell me how have you fixed it so it will never happen again. Someone asked me this yesterday, and because we've been having a lot of production issues, and they're saying, well, we have all these production issues, but if only we could get to every root cause and prevent it from happening again, things would be so much better. And I realized this was going to be a longer conversation than I had time for. Getting to the root cause of a production issue is not the answer, because it's very rare that this exactly the same root cause will happen multiple times, unless your organization is really, really bad at engineering. But it's very rare. It's more likely that different things will combine in different ways and cause different issues. So you get the most from production incident reviews by learning and sharing information about how people responded, how people diagnosed, how can they improve that response, that diagnosis, and what things can we start building into our engineering process and our components to improve their resilience. Chaos engineering helps in lots of different ways. It's not just about the product. It's not just about building in mechanisms, so increasing redundancy, putting in circuit breakers. It's more about the people and giving people the knowledge, the practice, the expertise at how to calmly and in a really focused way respond to a production issue, get to the root of the issue as quickly as possible and resolve it. It's also this knowledge helps them when they're designing their systems to think about, this will fail. How are we going to know if it fails? What should happen when it fails? It also improves our processes. Chaos engineering is great at giving us a space where we can have an incident, effectively a production incident that we're controlling and we can get the most from in terms of learnings. It does help the product as well, because it does show you where you've got gaps in your alerting, your observability, and where you have the need for a greater number of incidents, more compute power, or circuit breakers or some other mechanism. But that should be the last thing that you reflect on when you're going through this process. So we've learned about chaos engineering, why it's important, how we can use it, and let's talk now about a chaos state. So what is it? How do you know when to run it? And what's the mechanism for going through it? For a bit of background, the first time we did this was at a very large public sector platform that we've been involved in from the outset in terms of designing and building. It's a very, very large platform as a service. Serves several hundreds of millions of customers. It was very, very busy when coronavirus hit. There were lots of new services that we had to build very, very quickly to provide people with help that they needed during the pandemic. It's been designed around a set of about 6 platform teams that provide core services such as all the kind of CI and CD pipelines, the monitoring, observability, alerting, automated ways of setting up databases, automated ways of deploying microservices and monitoring those microservices. This platform is very, very big, and it generates a mass amount of traffic in terms of HTTP requests, but also log and metrics. And that kind of data, the logging and the metrics are really, really important for the teams themselves, because if there is an issue, they have to be able to see what's going wrong. Otherwise, you get a headline in the Daily Mail about something you did yesterday, which is not a pleasant experience. So with this in mind, we wanted to look at, how can we learn about the resilience of these systems? Not just the front-end systems, the ones that the public see, but the core underlying platform systems. How can we ensure that when there is a production issue, people can still see the logs for their service, they still get alerts, they can still deploy fixes? We started building this platform back in 2013. Back then, we were so cool. We were using all the latest tech, like Scala and Docker and Mongo. Kubernetes wasn't even maybe around or available to us then. AWS didn't have any data centers in the UK, so we had to use some private clouds. And it was a fun time. Just a small number of teams building lots of services. They were really successful, so the government threw more money at it. And it grew to tens of teams, tens of services. Those services became more busy with the public. lots of different things, so different services that people relied on were starting to be used on this platform. We had problems with our single private cloud, so we brought another private cloud provider in and went multi-active. Wouldn't recommend that. It was a bit of a nightmare, because now you've got two clouds that are slightly unreliable and you're having to load balance across the both. But we did it. We got to multi-active. So all this time, we were having quite a few production incidents. We were having 3 unplanned chaos days regularly, learning lots, but it was quite painful. So we weren't ready for chaos, no way. Not until around 2017, where finally AWS had a data center in the UK that our public sector client allowed us to move the platform to. The other big unlocking for us was that at this point now, we managed to convince the stakeholders that it was acceptable for any team to deploy production at any time. Up until then, one of our platform teams had to do every single production deployment for 60-odd teams who were deploying on a daily basis. So we didn't have much spare time, as you can imagine. But so once we achieved self-service deploys, and we're on AWS, we had very few production incidents. Our platform teams had a bit more time on their hands. We also had a key business event approaching at the end of January, which might give you a clue who this is. And we thought, wow, we're on AWS, we've got time on our hands, business event is in about 6 weeks away. Let's see what happens if we could, if we can break some things before that event so we can learn from it. So we planned our first chaos day sometime late December, and it was really good. Inspired this talk. So with that in mind, who do you involve in a chaos day? How do you decide where to run it, when to run it? We started off running with what I call a closed team. So we picked the people across these 6 platform teams who were the experts in each team. So we did that for 2 reasons. We wanted someone from each team that could have deep understanding of what kind of problems can happen, what kind of things does the team really not know enough about and understand enough, and if there was a problem, it would be very difficult to resolve. We chose these people also because they were the ones the team always went to when there was a production incident. So they had the highest bust factor. We wanted to simulate your most kind of excellent engineer, the person with all the knowledge, all the skills, being away, uncontactable, pretty much dead for the day. And this is you don't do anything drastic to that person, but it's a really useful way of simulating the worst possible situation. So we pulled those people together, one person from each team. Having done this now a few times, we've learned that it's actually also useful to be doing your chaos day planning and design in the open, where you involve as many people as possible, because the actual process of thinking about what experiments you're going to run and designing those experiments, you learn an awful lot from that process. And the element of surprise that you learn by having a kind of closed team, you can make up for with the extra knowledge that you get spread around. So we formed this team, we called them the Agents of Chaos, and we locked them in a room and a private Slack channel. The next thing we did was got that team together with a big whiteboard and said, okay, let's map out our architecture. Let's sketch out what does a busy day look like. We have a big business event coming up. What kind of traffic do we normally expect? How do we know that our system is healthy? And which parts of the system, if they were to fail, should we be able to do something about? Should we be able to rectify, remediate? Which parts of the system can we not do anything about? So we were reliant on some third-party legacy systems that, if they went down, all we could do was fail gracefully. We couldn't, magic them up again. We had to wait for those providers to resolve those situations. So those systems were out of scope for us. But we could simulate the network connections to them going down, because we had to be able to have some kind of resilience in those network connections and to be able to kind of gracefully switch from one to the other. We also agreed what parts of the system do we not want to experiment on. So for instance, these kind of legacy components, we didn't want to do a denial of service attack on them accidentally through the chaos day. We wanted to make sure that they were protected. So we set up some constraints and boundaries for our chaos day. We agreed what our architecture was, what steady state looked like, how we knew things were healthy. So with that diagram in mind, we then gave the team this goal: come up with 10, 20 experiments that are things that you're really worried about. So just describe, if this failure happens, I would be really worried, especially if it happened on the key business event. I wouldn't know what to do, or I don't think it would self-heal, we'd know about it. So we just put these experts in a room and trusted them to think up some great experiments to run that would help us to learn a lot more about the resilience of our platform. So they did that for about an hour or so, came up with lots of different ideas. The next step was to prioritize them, because you only have a limited amount of time for running these days. They are quite a big investment. So they prioritized the top 10 different experiments and then formed them using this kind of template. So describe what is the component that we're causing the failure in, what's the failure, and what are we expecting to happen? What's our hypothesis about what we'll see? Because we're running this across 6 platform teams, we labeled, and this is using Trello, which teams were being involved here, because sometimes a failure would span across multiple teams. Then we documented more details on the failure that we're causing. How are we going to simulate this failure? Can we actually directly cause it, or do we have to simulate it in some way? What visible impact do we expect to see? How will this show up in our monitoring or alerting? How will it show up to the customer? And how are we expecting teams to respond? Do we expect to have people alerted within a few seconds, people to jump on it and resolve within a few minutes? Or we're expecting some automated self-healing to kick in? Then, most importantly, they had to write down, what do we do if people don't notice and they can't fix it? Because you don't want to leave your system completely broken. You need to know how you're going to put things back to normal, how you're going to fix it yourself if the rest of the team are unable to resolve this. When we ran this our first time, it took us a few days to put some of our systems back. So it is quite important to know how you're going to fix things on the day itself. And then also link to any other cards that you want to run in parallel. Chaos days are a great occasion to also test out the security of your system and the awareness about security within your team. So I'd encourage you, when you're running a chaos day or running chaos experiments, simulate some kind of security attack, either someone from the outside trying to attack your system, trying to run a denial of service attack. Also simulate an engineer that has turned very unhappy and decided they want to cause problems themselves. And just try and check, how far can people go on your platform unnoticed when they start causing problems? So we had a security team within our platform teams, and they started designing some security experiments that we'd run in parallel to the kind of failures that we're injecting. So with your experiments designed, prioritized, you've got a list, you've got the team ready to run them. You need to decide now, where are you going to run these experiments? Chaos engineering was made famous by Netflix running Chaos Monkey automatically the whole time in production. And they did that for very good reason, because their engineers weren't designing their services to handle their hosts kind of failing either unexpectedly or in a planned way. And so the team at Netflix forced them to start designing their services better by randomly shutting the host down. Now, they did run that in production, and they still do, but they put an awful lot of thought into that, and there was a lot of kind of safeguards put in place. You don't need to run your chaos experiments in production, and people from Netflix have written about this themselves. It's just important that you choose an environment that's as like production as possible, because if all your environments like cookie cutter environments that are very similar, then the learning you get from one you can also apply to another. If your environments are completely different, then that's a different story, and you've probably got a bigger problem you need to worry about. So choose an environment that is either production, if you can do it safely, or as like it as possible. If it's not production, you need to think about the load. How are you going to simulate enough load going through your services so that when the failure happens, alerts and different issues will be triggered? Consider what kind of observability you have in your pre-production environments. So for instance, alerting is quite a common one, that generally people have alerting enabled in production. But do you have alerting of any kind enabled in your pre-production environments? Has it been turned off? Can you turn it back on again? Can you change the thresholds for those alerts? Think about the blast radius as well. this applies to any environment. So are there parts of your system that when chaos starts happening and things start failing, you definitely don't want those components to fail? So it might be that if you're doing something in your staging environment or development environment, that another team has got a critical delivery that they're working on. So they're going to get really hacked off if you start breaking things a day before they're supposed to go live. Finally, decide on where are you going to communicate when these problems start happening. So our practice was that we had a public Slack channel for each, public within the organization, Slack channel for each environment to just talk about any issues we saw in that environment. And so we had one for production, staging, etc. So we decided that if there are any issues happening in an environment, we would talk about it in that standard channel, and that was the same for the chaos day. And that just helps people get into the habit of working as though they would on a normal day. Then you need to decide when you're going to do this. The first couple of times we did this, we had a single day. We found out from other teams what was happening around that event, and to ensure that we weren't picking a day that was a critical delivery or very near a critical delivery. We also decided that we should give the teams some warning, just so that they could get the most out of that day itself. But they didn't know what time we were going to start running each experiment and when the different experiments were going to happen. But you need to consider what else is happening in your organization, because this kind of day can be disruptive, especially if things go badly wrong. You also need to agree at what point are people going to stop breaking things and put everything back to normal. And as I said, when we first did this, it took several days to restore normal service in our environment, and we learned from that, fortunately. Something else about when. As we've got better at doing this in different organizations, we've actually tried running a chaos week. So we agree a week when we're going to start doing experiments. We don't tell people what we're going to run during that week, but we'll start running different things on different days. That increases the element of surprise, but also helps you learn more about the experiments you're running as you're running them, and then tweak experiments you run later in the week. And we've found that really useful. If you get to a point where you can automatically run different chaos experiments using some of the tools that I've linked to, that's also a great situation to be in, because then you have experiments running at a low level in the background all the time. So you've got the team together, you've worked out what experiments you're going to run, you know where you're going to run it, you know how you're going to communicate. It's the time to let the chaos unleash. So a few things to focus on. So firstly, with the people that are running the experiments, try and get them together either in a virtual room or a physical room, because where you have multiple teams on a large platform needing to coordinate on causing chaos, it's important that they can talk to each other really easily, particularly if there's experiments that impact each other. Have one person facilitate this, because running a chaos day can be quite intense and exciting, and people can get a bit carried away trying to break things and try and inflict the maximum damage. It's not about breaking things, it's about learning. So you need someone who can facilitate and ensure that people just limit the length of time the experiments run. So if teams haven't noticed or haven't been able to fix something within 10, 15 minutes, maybe 20 minutes, then perhaps stop the experiment, restore normal service, and move on to the next experiment. So there's more you can learn in a different area. The team also need help in documenting what they're doing. It's good to treat these kind of experiments just like a regular production incident, where it's really helpful if you can document who's doing what when, who notices what things have surprised you, how did you know to make a change to a particular configuration, so that when you review the day afterwards, you get the most learning from the whole day. For everyone else on your system that is just working as normal, stress that this is just another day's work. You don't want people sat looking at monitors, looking at logs, waiting for the next alert to go off. You want people busy doing their regular day's work and not panicking. Very important. They need to imagine that any failures that are going to happen are just like they'll be happening on production. So use your standard production instant response process. If you have people within your team that are on call, use those people just like you would regularly. Follow your standard process, document what they see, how they respond, how they resolve things, so that you can then do effectively a postmortem afterwards. Use whatever channel and communication means you would for a normal production issue. So we used Slack quite heavily in different organizations for this as a great way of effectively providing a timeline of what's happening when, and people can post graphs and other things that they've seen into those channels. PagerDuty is kind of similar, so combining the both works really well. That whole process of designing the experiments, running them, is a great kind of learning tool. People learn so much about their system because different knowledge comes out from other people, and as you design these experiments and test them out before the day, you learn a lot about how your system behaves when things go wrong. Then you get even more learning by running postmortems. And when you're running this on a large kind of platform, because you're having multiple teams involved, we split the postmortem process or retrospective process so that we had each team run their own retrospective where they looked at all the issues that they responded to. They did a standard type of postmortem on them. And they considered, okay, what have we learnt about how our people respond? What kind of things have we learnt about the knowledge that's in different parts of our teams? What have we learnt about the processes that we use to respond to issues? And then finally, are there any changes that we think we can make to our product to make it more resilient, to improve the observability, for instance? Also consider the chaos day itself. What can we do to make this process easier, get more learning from it the next time? So summarize all those learnings within the team, try and document them, share them, and then bring one person from each of those teams together for a team of team retros to share the highlights. And we found that was a really good way of getting the most out of the chaos day itself. It's important to plan this ahead of the actual chaos day so that people have got time aside within a day or two of the chaos day so that learning and information is still fresh in their minds. Just with post-incident reviews, you get the most learning from them if the more people that read them. So try and share these kind of write-ups as widely as possible, and also write them well. It's important that a post-incident review is engaging, so that when people read it, they are gripped by it. They want to turn the page and understand, what did they find out? How did they resolve it? What happened next? Because by people reading it, getting that knowledge into their heads, that helps them become better engineers, helps them to understand their systems more and be able to respond better the next time something happens. We've done this quite a few times now, so what have we learned? What advice can I give you if you're thinking of doing this yourself? They definitely start small. It's very easy to get carried away doing a chaos day and design lots of experiments to break lots of things and frustrate lots of people. So only choose, in terms of how many you actually run, maybe 5 experiments on a single day. And focus on experiments that don't inflict the maximum pain, but actually help you learn the most. To focus on parts of your system that, if it failed, you just don't know what would happen, and you're worried that it might, cause a major headline in your company or still in the newspapers. You don't need to use production as well. Look at your environments. Think about how like production they are, and if you have production-like environments, just use one of them. Learn as much as you can from these events. This event is not about causing pain or breaking things. It's about learning how our systems fail, how do our people notice those failures, how do they respond, and using that learning to improve resilience of the overall system, so people, process, and product. And most importantly, have fun. They're a great way of bonding a team, helping new people get to know your team and your processes and your systems, and generally sharing knowledge, particularly across multiple teams. If you've got 6 or more teams, it's a really good way of bringing people together across those teams and helping them understand each other a lot better, which will also help when you have major production outages. So have a think about the talk and what you might do next. And I encourage you to reflect on, where is your organization at, or you personally at in your journey with chaos engineering? Have you considered running any experiments before? Is it something that you're doing already? What's the next step you can take to improve your team and your organization, your system's resilience? We're happy to chat with you. So Equal Experts have done quite a lot of work in this area. We've written an open source playbook on this that is available on the link that I'll share in these slides later. So we'd be very happy to help give you any advice you'd like on this. thank you very much for listening. We've got 10 minutes left, so it'd be really great to take some questions if people have got any. Thanks. Okay, what else would people like to know? Any questions?
I guess the first question is sort of when you sort of introduce this concept to, I guess, the business, the idea of saying, hey, we want to do this, we want to like cause these production outages and there's going to be disruption to business. Like, what did you do to sort of convince them that this was a good idea? Like, what approach did you take to say, no, this is something we should do? Sure,
a good question. So you're asking about how do we convince the business that this was a good thing to do? There's a few different things you need to consider. So one is the cost, and the cost of doing this in a planned, controlled way versus the cost of an unplanned chaos day. We worked out, how much of people's time would this involve, and what kind of learnings would we get out from it. We also then considered what things were we worried about. Should our stakeholders be worried about if something goes wrong? In this particular organisation where we did this the first time, the key business event was, the organisation's one of their busiest days, and we realised that we had an opportunity to give our stakeholders more confidence that day would go well by running these experiments about a month ahead of time. And we estimated it would only cost us probably about 1 or 2 days effort for across the teams that were involved. So I think it's important to have a conversation with your stakeholders about their concerns. What are they worried about, and how would they feel if something went wrong on the day? What are their thoughts on this approach to reduce the risk of things going wrong, or if things go wrong, people responding better? Anytime you're in an organization that is either doing something new with their system, like replacing a major component, or as a significant business event coming up and they've had problems in the past, it's a good time to have this conversation at least 3 months beforehand. Does that answer your question? Thank you. What else would people like to know?
Could you give some examples for what kind of failures to introduce? Like, would you manipulate a service and make it not do what it should do, or would you just kill stuff or manipulate the network? Or
sure. Okay. So, what kind of failures did we like to try and run? So we do things like fill up a disk. So see what happened there. We would. When we had different network connections, we would take down one of the networking components to see whether instances would automatically switch over. We had, so we were in AWS, and we had kind of the self-healing mechanism that was linked into our own kind of CD system, because we weren't using Kubernetes. So we wanted to test how well that worked. So we started killing different instances just to check that they would recover. We also broke different parts of our telemetry. So we caused a failure in one part of our telemetry system to see, if people can't see one type of logs, where else could they go for information? What else did we do? We caused problems for our CI and CD system. So because this platform was very large, we used infrastructure as code an awful lot. So we had a kind of CI/CD system that was completely automated in terms of setting itself up. So we had the confidence to try and take that down, so try and break our CI/CD system to the point where you had to completely rebuild it. that was a brave thing to do, but it was really good learning. We also, to kind of ensure there's a lot of control in terms of what things people could access, people had to have special kind of accounts to log into different things, and we kind of broke the system that does authentication to understand, so when the team that owns the authentication system sees that failure, how do they know to resolve it? And that was a very good test, because the one person that knew how to fix it was our agent of chaos, and he was effectively dead for that day. And they ended up going and getting him out of the room to resolve it. So that helps to give you an idea. Okay. All right. What else? We've got 5 minutes left. Any other questions?
So one of the suggestions I think you made was to use the same communications channels and mechanisms that you would use for a real live incident.
Yes.
I found myself worrying when you said that. On the one hand, it might be distracting to other folks in the organisation. And on the other hand, if God forbid a real live incident happens, how do you ensure it doesn't mask that or cause it to take longer to notice that that's going on?
Good question. I think so the caveat would be you choose an environment. So if you choose production and you're running chaos experiments in production, they could well be production issues. So you should probably use the same channel as you would for a real production issue. When we were using pre-production environments, which is what we've mostly done, we used the same channel there for the same reason that people were simulating failures that were having impact. So people needed to respond in a way that was visible to other people for that environment. Does that make sense?
Yeah, I think so. Thank you very much.
Okay, thanks. So the question at the back?
Just a suggestion as a follow-up to what was asked just then. In the military, when they do exercises to simulate things going bad, they have a thing called the safeguard rule. And when actual things go bad during the practices, then they just announce that it's safeguard, and then everybody knows it's for real. And so implementing something like that during a chaos day gives a really clear way of people understanding when something bad has actually happened and it's not an exercise.
Thank you. That's a really good suggestion. Thank you. Another question at the front.
Have you ever run chaos tests on the communication systems themselves?
We were using Slack, so that was very hard for us to kind of break itself.
Yeah, I mean, just saying you can't use Slack. Let's assume Slack is down or something.
We did consider that. I think Slack had a few failures over the last couple of years, so we had some free chaos days where we had to experiment with different forms of communicating. That was quite hard work, so it would be a good thing to try out. I would recommend it, but it wasn't something we focused on. Yeah, it's a good idea having an agreed backup. And the same for your run books. So something we realized is that all of our run books were stored in Confluence, and we simulated Confluence going down. And that we didn't realize until we simulated that failure, so we did take Confluence down. We had our own private hosted Confluence, that people couldn't access their run books. And that was a great learning for us because it made us realize, well, we need to have a backup that's easily accessible of all of our run books, that's automated and the rest of it, because it took them a long time to restore Confluence. So thanks, good question. Okay, we've got 2 minutes left. If you've got more questions, I'll be hanging around afterwards outside. Also, there's lots more information in the playbook, so I'd encourage you to check that out. So thank you very much for your time and your questions.